do one question, and I'll put this up. Those that weren't here, obviously you got the worksheet from the internet.
15.
15?
Yep. Do it.
Let's see. All right, on 15. Assuming that a raised to the b x to the n dx, b, oh, you guys don't read it like this. Oh, don't sell yourself short. That's the worst thing to do. What do you get? I'll be honest that you don't know how to integrate this, so how do you multiply that out first? Today, you might learn how to integrate this. Yeah, you would pull it out. So it'd be from 1 to 4 of x minus 10 square root of x plus 25 all dx. Okay? This right here? Oh, I'm not done yet. Those are a and b, and you don't use them until after you take the antiderivative. So, I haven't taken the antiderivative yet. I'm getting ready to. The antiderivative would be x squared, so you're going to divide by 2, so it's 1/2 x squared. And then, since the square root of x is already a half, that'd be 3/2, right? So it'd be 2/3 times 10x to the 3/2. You got to multiply that, of course. So far, so good on the antiderivative? And then this becomes plus 25x to the first divided by 1. The only reason I put that on there is x to the n means you should do this for each term. I'm not going to write like that, but that means you add 1, divide by 1. That's how you take the antiderivative, correct? So this part here just means the antiderivative. And what notation did we use for the antiderivative starting last week? No, that meant to take the antiderivative, capital F. So this actually equals capital F, doesn't it? Of x. What this notation says is you take the capital F of the function value of b. You see how b is in place of the x?
Yeah.
And subtract what happens if you put in a, because a is in the x. So that's what the 4 and the 1 are for. When it's written like this, the 1 and the 4. That means I put 4 in first. So I have 1/2 4 squared minus 20/3 4 to the 3/2 plus 25 times 4. Here comes the fatal mistake made by a lot of people in the second semester. Yes, as far as the difference between an A and an F on a test. They subtract the whole thing. I mean, you're supposed to subtract the whole thing. Some people just subtract the first term. You subtract 1/2, 1 squared, minus 20/3, 1 to the 3/2, plus 25 times 1. Then you close it off. So you subtract all that. When you're done, I don't know, this is 16, this is 8, 2, 8, 160/3 plus 100 minus 1/2 plus 20/3 minus 25. That's what happens when you work out all the arithmetic. Now you just combine it all and get your answer and hope it's one of your choices. If not, probably made a mistake in your arithmetic. 8 and 100 is 108. 108. Negative 160 plus 120 is minus 140 thirds. That takes care of those two. Negative 1/2, negative 25, negative 25 and 1/2. Thank you. Taylor? All right. So, what is this going to equal if you punch it out? Which one of the following?
215 over 6.
What is it?
215 over 6.
Oh, is that one of your answers?
Yep.
Is it really? Nice. 215 over 6. Okay? So go ahead. Yeah?
So is it because they didn't
Correct. Remember, quiet please. This, when it's written like this, is not an indefinite integral, but a definite integral. When you have a definite integral, you're going to have a numerical answer. If you don't have those numbers, you're going to have a plus c with an equation for your answer. That is your first question involving a definite integral. All right? Go ahead and hand the rest of them up. Hand them over. Alyssa will place them on my desk, and I'll try to get them graded this week.
I wish I had take one.
So that just
Huh? You have a quiz over 5-2 Thursday or Friday. It's like this.
that's just the difference between two derivatives.
Right. Two antiderivative values. All right. With that said, slideshow from the beginning. All right. Those of you that never got the chain rule for taking the derivative, this is your third integration rule. This one is used the most. This one is also the most difficult to understand in my experience. I have tried to teach this a different way every year since I've been teaching this course, trying to figure out the best way of doing it. One year, the new way seems to work, but then there's always a third of the people that don't get it. Well, then half of those people end up picking it up, so it's fine. This is integrating a composite function using U substitution. Yes, it sounds very dry, but it's also very powerful. Any integral that you can integrate, you can do this with, up till now. In your list of integrations, this one isn't even listed. No, it's not. Huh? Oh, yeah. First of all, what is a composite function? That's the whole key. What is a composite function? Landon, since Jolie's listening. Landon. No, she wouldn't know. I couldn't hear her response. A composite function. Give me an example of an equation that has a function within another function.
What does that mean?
Yeah, what's a function? Give me an example of a function. Let's start first. What's a function? Let's just do function first. Okay, let's make it a little bit more. Let's go plus 7. That is a function. Let's call it f of x. Okay? G of x. Let's call another function is
X cubed plus 10.
or the square root of x plus
10.
1. Now, a composite function, f of g of x, is a composite function. You take g, you put it into square root plus 7. That's a composite function. G of f of x. G of f of x is also the square root, parentheses, x squared plus 7 plus 1. Those are composite functions. You get the idea from just looking at that. Those are how you integrate complicated expressions that you can't do the simple power rule or the simple trig rules with. Okay? You had a problem earlier. Kyle actually got this problem right, in which it was the sine of 4x, and you had to integrate it. Where does the parentheses go around sine of 4x if you're going to put it in your calculator? Yeah?
4x.
Around the 4x. So that is a composite function. The inside function is 4x. The outside function is sine of x. Don't introduce any other variables. So it's a combination of sine of x and 4x. Okay? Ooh, I just thought of a 16th way to teach this. I think I'm going to give it a shot right now. Yeah, this is my 16th attempt at teaching this in high school. In college, you just kind of ramble through the definition and be done. Okay? No, I'm trying. Whenever I teach this, I always try for 100% on the first week. I'm always trying to get that. So anyway, the outside function is sine of x, correct? If I were to take the antiderivative, I think I'll stick with trig functions. I've never done that before, but I'll give it a go. If, no, I'm fine because I'm thinking.
You mean that one? Yeah.
Sine of x and 4x, I think I'll go with this. F of x equals sine of x. And what's the antiderivative of sine of x? Negative cosine of x, correct? Okay. And if we say g of x is 4x, what is capital g of x, the antiderivative of g? 2x squared. Okay? So if I want to integrate this integral, there's a couple ways you can look at it. Sine of x, negative cosine. Yeah. If we look at sine of 4x dx, this doesn't hit one of my rules right now, does it? So, if I let u equal 4x, all of a sudden I get the sine of u. Okay? Now, in the first one, if I have 4x, this dx tells me my variable is going to be x, right? So far, so good? How do you take the derivative of u? How do you label it? How do you make a notation to tell somebody you took the derivative if it's in your work for a line-by-line work? U prime's one way. What's another way? Yeah, du over dx. The derivative with u with respect to x is 4. Correct? Okay. If I'm going to make a change, if I'm going to change this to a u, I have to change this to a du. So I can take the antiderivative. So, take a look at something. For every 1 du, it equals 4 dx's. For every 1 du, it equals 4 dx's. Or another way of looking at it, for every 1/4 du, it equals 1 dx. Does that make sense? That's great. In place of that dx, I can put in 1/4 du. Now, according to the inside front cover of my textbook, I can integrate sine u du. In fact, it has all the u's in it already if you take a look. What is the integration of sine u du? All those are written with u substitution in mind. Negative cosine of u plus c. See, we are close. The antiderivative of sine is negative cosine. Fantastic. So, what do I put in place of u? What does u equal? 4x. So my final answer is negative 1/4 cosine 4x plus c. Okay? Fantastic.
So if we just learned this, how were we supposed to do number 8 on
Oh, you just had to think it going backwards. Remember before I showed you the power rule? You can just think your way backwards. If you had sine of 4x, you knew if I went backwards, I'd have 1/4 or negative 1/4 cosine of 4x. You just think, there's only one problem, you just thought your way backwards to do it. On these, though, now we're talking about a definite way of doing it. The whole key to this is, very simply, if you have to put in your calculator, where would you put the parentheses? And that's usually 99% of the time what u is going to equal. So on this one, the square root of 5x plus 7. Where would you put the parentheses if you typed it in your TI? Okay, around the 5x plus 7. You can't integrate this the way it's written. You don't have anything for the square root of 5x. However, if you're going to place this with u, you do have something for u to the 1/2. That's easy. You can integrate u to the 1/2. You can add. You have that. Over here, some scratch work for your substitution. If u is equal to 5x plus 7, that's your first substitution. Your second substitution is you have to account for the dx. What's the only way to get dx into the problem? You have to take the derivative. The derivative of u with respect to x equals 5. So, that tells me that 1 du is worth 5 dx's. How many dx's do I have? I have 1. So that means, well, 1/5 du's equals 1 dx. And remember, I told you I use this all the time. Where do I always put numbers at in an integral? Well, I always put them out in front. 1/5 is going to go out in front because it's a numerical thing. The u to the 1/2 is my substitution. And then I can put a du right there. So the 1/5 du all came from the substitution for dx. The u to the 1/2 came from the substitution for u equaling 5x plus 7. It's a two-step operation to allow you to integrate now. You can integrate this because that is inside the front cover of your book. You add and you divide. 1/2, we already said was going to be 2/3. U to the 3/2 plus c. One thing you have to understand about this textbook, about your work, about everything else. If it's an indefinite integral, which this is, if it starts in x's, your answer has to have x's in it. You have to put your 5x plus 7 back in. Yep. Oh, 1/5, sorry. Should be 1/5. 1/5. Okay? So your final answer, since this is an indefinite integral, that means no numbers. I have to put my answer back in terms of x's. 2/15 times 5x plus 7 to 3/2 plus c. If you want to take the derivative, you have to use the chain rule. This is not known as the opposite of the chain rule, the inverse of the chain rule, or anything like that. It's known as use substitution integration. Because there's also called UV substitution integration. That's where you're doing two substitutions at once. That starts in Calc 2. We used to do it here at St. Joe, but since it's our dual credit, we don't get that far. Anyway, that's your final answer. Use substitution. When do you use substitution? What types of functions? Landon. Composite functions. I didn't ask that because I wanted Landon to give applause. I wanted to know, I said the answer to the first question on the quiz for Thursday already.
Composite.
What? That's okay. I'll be here Friday. Anything else? Let's give it a go. Yes? It doesn't matter. That's the great thing about it.
It's not that expensive.
Moving on. Oh, already did that. I forgot. I already had the answers up here. Oh, no, we're not.
We can just take a whole day of brain breaks. Yeah.
Here we go. Cosine of 4x dx. This should be easy. Give this a go on your own. What we did with sine. There's a slight difference between sine and cosine. I'm going to walk around and take a look and see if you can do it. Sure. Do you have a copy of it? No, I don't. Okay. All right, Lenny and Anson, you guys done? Not exactly. Close.
There's two
Minor details.
Minor details. So far, so good? Everybody picked the same thing for you?
Yeah.
All right. That we got? Anybody have a negative? That's usually a common mistake.
I did that at first, and I'm like, whoa, we're taking the antiderivative.
We are taking the antiderivative. It says the antiderivative cosine is sine. And don't forget, you don't write 1/4 times c. 1/4 times a constant is still a constant. Don't get caught in that. It'll throw off your answers when you're doing differential equations. You don't multiply that through. Okay?
Okay.
Fantastic. I don't have one.
What?
They have a whole CD.
I've gone through, there's only 50 of them on there to begin with.
Just make one up real.
We've done 50.
Something. All it has to do is cross over the brain.
All right, all it has to do is cross over.
Just like that. Different type of number.
Did we multiply? Did we do the right shoulder, left shoulder multiply?
Let's do like
We
the
did?
under one. I was thinking- Yeah, we should do that one again. A lot of people miss that.
No, they didn't. Huh? We spelled it out? No, this one's different. You need groups of 3.
Do it like-
We need groups of 3? All right, go ahead and get in groups of 3. And you can't have 3 PBO people together. It won't work.
We're not very good at this usually.
All right. Time for a brain break.
That's me.
Okay, I think we did this one, but I changed it just today. Oh, right shoulder. Mason, come back up here. Right shoulder is a 1. Right ear is a 2. Slitter is a 3. Nose. 4 is left ear. 5 is right shoulder. I changed it because this person is going to hit 4 digits, and these two are having a competition to see which one can get it first.
Multiply them?
Yeah, multiply the 4 numbers.
I'll be the
Bring Oren up here. All right, so one person is giving the numbers. The other 2 are competing to see who gets it. Then the winner gets to flash the numbers to the other 2. Okay?
60. Got it.
Nice job. Now you go. All right, go. No, easy. Ohio State got beat. Oh, yeah, they did. Okay, never mind.
Yeah, they cleaned up ugly.
Huh? Shoulder.
Those look like elbows.
Shoulder. Okay, go ahead. Go ahead. 1-1-1. Good.
I thought that was. I thought it was.
Oh, okay, go ahead. See, he kept, every time you do something, he'd cheat. He'd look at the number. All right, spin it, and then all you have to do is, yeah, you go.
Sure. I don't know.
Oh,
Undefeated.
Ohio State got beat.
At what?
Wrestling. Wrestling.
Number 2 in basketball. I don't think they got the football.
All right, one more time, hurry up. 8. All right.
12.
All right, have a seat. All right, have a seat. All right. So, undefeated. Now, in your book, in your textbook, when you start doing the problems, they will tell you which one to pick for you. I don't think this is nice because I will never tell you what to pick for you. And you can see right away, one, if you're to type it out, there's 2 sets of parentheses you could use. But the one you have to use is around the x squared minus 3. So it still follows that little guideline that if you're going to type it out, that is your u substitution. Lauren?
Can you just make it like u to the negative 1 half of
Exactly.
What happens if you have like 2 parentheses in one? Like if you have,
Then you have the choice to make.
so like if you had cosine of 4x over that, which one would you choose?
I'd probably do u v integration.
Oh, that's when that.
Right.
Could you do it using like 5x over x and then using the
No, because you can't take the square root of x squared minus 3.
Okay.
All right, so back in the back. Kyle, what's the derivative of, well, first of all, I have the square root of u. Oh, sorry, Kyle. What is the derivative of x squared minus 3?
2x.
Okay, so I have du dx equals 2x. Now this one's slightly different because that's a variable after you take the derivative. There's a couple of ways of handling that. I'm going to multiply the dx over. Du equals 2x dx. Now, the x and the dx isn't so bad. I prefer to do this at one time. Some people prefer to do in 2 steps. I always think that I have to get rid of the 5x dx. Okay? How can you make a 2x dx into a 5x dx? Multiply both sides by what?
No.
Yeah, 5 halves. If you multiply both sides by 5 halves, the 2's cough off. So 5 halves du equals 5x dx. So that would work. So I have the 5 halves du. I can put a 1 right there if I want. I'm going to flip it anyway. And that can work out as usual. So the 5x dx went with the du substitution. The x squared minus 3 went with the u substitution, and the square root stayed there to be integrated. So there are ways of doing that, except one, you can't put a variable out in front, And you want to make sure everything's in terms of u and du. So, now you do is integrate it. 5 halves, u to the negative 1/2 du. Let's see, add 1 to be 1/2, divided to be 2. So 2 times 5 halves, u to the 1/2 plus c. So we end up being 5 square root x squared minus 3 plus c. Yeah, I think that works.
So we don't have to worry about the 5 halves multiplying by C. That doesn't have to-
No, right.
What about, okay, that's like, don't you have 5? Is it negative half?
Yeah, I did. I used the whole 5x dx
Oh, okay.
in place of the 5 halves du. Okay? I don't know if that's right. Let's find out. Yeah, 5x squared minus 3 plus c. Excellent. Go ahead and give this one a go.
I don't know about that.
U. They even tell you what U is. And this goes back to what Mason said. What if you have a choice of 2? You pick one. If it doesn't work, you do your math and pencil anyway. You try the next one. But remember, wherever you pick for U, you're going to have to take the derivative of. And sometimes that's not always.
Yikes.
So they're telling you, let U be tangent. So some people are using the front cover for the derivatives and the antiderivatives. Well, what's the derivative of U? What's the derivative of tangent? It's inside your book. It's right there. It is.
It's already in there.
So that means in place of this whole secant squared, you can put in du. In place of the u, in place of the tangent, you can put in the u. So, or now, how do you integrate u du? You do too. This is from last week. And I'll bet you turned in a completed problem that had this in it. You have a 1. Very good. 1/2 plus, very good, 1/2 u squared plus c. So that becomes 1/2 u squared plus c. You replace the u with tangent. It becomes 1/2 tangent squared of x plus c. And the trig ones are the ones that you might pick the wrong one for. Let me go off to the side and say this. This isn't going to be on the notes, but nevertheless, it's still worth writing. If I want to pick u, if I follow my rule, and I have tangent x, secant of x squared dx. If I pick u as secant, what's the derivative of secant? Secant x tangent of x. Du dx equals secant of x tangent of x. Notice one thing. No, it's not harder. It's one thing you're going to notice about trig problems the entire second semester. If I have du equals secant of x tangent of x dx. I can put in place of u, I can put in secant, right? In place of tangent x, secant x dx, what can I put in? Du. So now I have u du. How do you integrate u du? Same way. 1/2 u squared plus c. Have I made any mathematical mistakes in any of the arguments or any of the substitutions? Yet this integral equals 1/2 secant squared x plus c. But that's not what we got for our answer. We got 1/2 tangent squared plus c. Can an integral equal two different things? For one, don't forget it's an indefinite integral, not definite. So definite gives you a numerical answer. Two, what is the Pythagorean identity between tangent and secant, say? What's secant squared equal? It equals what? It equals what? Tangent squared of x plus 1 plus c. Okay? So what is, if I multiply this through, watch what happens. I have 1/2 tangent squared plus 1/2 plus c. What is 1/2 plus c going to be? It's going to be another constant. When you work these out and check your answers, you might think you're not even close. Through the Pythagorean substitutions, or any of the substitutions, your answer could be just as right as the other one because you've got a huge constant right here that takes a bunch of numbers. Now, if you're with definite integrals, it's easier to check because you have one answer. With indefinite integrals and trig, you have the possibility of two completely different looking answers that mean exactly the same thing. So you have to be careful when checking trig indefinite integral solutions. Okay? Did that line of logic mess anybody up for the day? Okay, good. Question? Yeah. Either way. Sure.
So we went all the way through and we saw we had the wrong answer. Can we just go back and basically see the other one?
Yeah. All right. So that was good. Oh, this one. S squared plus S all squared ds. No. Now this one is here for one. I'm going to save you the time and trouble. This one is to prevent you from running around trying to use substitution on every single problem that has parentheses. This one has parentheses, but you don't use substitution. Why not? Easy. What would you let u equal? S squared plus 1. What's the derivative of that? 2s. Do you have an s outside the parentheses you can use for substitution? No. Therefore, you can't do it by use substitution. So the only way to do it is by multiplying it out, like we did on the square root of x plus 5 all squared, or minus 5 all squared. So sometimes you can't do use substitution because you don't have an extra s ds outside the parentheses. And that's the indicator that you can't do it. So you simply multiply it out, integrate each one, and you go on your way. So there are some limitations to use substitution. It doesn't apply to every single problem with parentheses, but if it doesn't apply, it tells you exactly how to do it. You have to go back to one of the two ways, either the trig functions inside the front cover or the individual power rules for all the polynomials. So this one's 1/5 s to the 5th plus 3s cubed plus s plus c. Nice. Okay. Questions on that?
So if there's just a number and a constant, like why can't?
Well, you see the s squared plus 1, that would all have been u, right? So I had u squared. Well, I can take the 2 over, and I got a ds, but I don't have anything for the plane s.
Oh, so there has to be something else in the.
Right, there would have to be an s right here for you to do that. Okay, and there's not, so you can't. Questions on that? We got 3 days on this before it's time for you to step up and do it on your own. I know, and the student solutions, I believe, are already online.
Good. Love that.
I don't think we'll do this one because, well, we can. It'd be easy. What would you let be you? You got a choice. 1 plus 1 over x or 1 over x squared. That's what I would pick, 1 plus 1 over x. The derivative is negative 1 over x squared. I got 1 over x squared. Yeah, so it's pretty easy. U substitution makes difficult problems look very easy to integrate. That's why when people say I don't know how to do it, I think you got to give it just a little bit of a shot and you'll be fine. Not talking about anybody in particular or an Alan. So, you end up with 1/2, 1 plus 1 over x. No, it wasn't. No. No. I don't think so. No. All right, so I'm going to go ahead and give you your homework. I did check. Next week, I believe you get angel accounts from Miss Ryan.
What if we already have one?
Then you have access. Yeah. Page 255, 1 through 17. I'll go back and then I'll go forward. You can check your Parkland emails. But you get a piece of paper from Miss Ryan. No, Miss Ryan has final say. Well, actually, I had final say and they took it away from me. No.
Does that, like we're filling things out, does that count as like an AP class or like a junior college?
You have to ask Miss Ryan. It's actually a junior college class. Okay? No, I don't want a nifty little pin. All right. Where's my? Here it is.